Now we come to the last part in probability that you learn the idea in junior form, which is called expected value. But let's see how we are integrating it in a more in-depth sense in probability. So first of all, in expected value is simply called sum of probability times the value itself. What does that mean? So let's take a look in example 45 here. You're choosing two fair coins. Fair coins, that means 1/2, 1/2 for head and tail. So now there are several situations. First, two heads are shown, 10 points. Two tails shown, 20 points deducted. So read the quick keywords carefully, deducted. Okay, last will be one head, one tail, 5 points. So that's why you can see there are some situations with certain value, that means the points over there. And you are asked to find the expected value of the question. So what was the situation now? If you write the expression very in separate steps, you have, so if the probability of getting two heads will be 1/2, 1/2, or you can directly write 1/4. Two tails, so 1/4, while one head, one tail, one head, one tail, so is 2/4, which is 1/2. So you first calculate the probability one by one. If you can't get it very quickly, so you can list out the outcomes. When you toss a coin, so you have these four results: head, 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 tail, tail, head, and tail, tail, totally 4. So that's why you get the three probabilities on the left hand side respectively. So when you're talking about expected value, so which is two head, probability is 1/4, 10 pounds multiplied together. Next, tail, tail, 1/4 minus not minus 5, minus 20, 20 pounds deducted. Finally, one head, one tail, 5 pounds, 5 pounds, then you add them together. This is the definition of expected value. So by chance, at last the outcome is 0. That is. So this is the very original idea of your understanding of expected value. But what does it use? Somehow I would say expected value is for judging whether you play a game or not, or is it fair to you. Okay, so I give you a situation is, do you like to play this game? Or kind of, actually it's like gambling, play the game for you. Okay, so your cost now I'm asking you. So each time when you play this game with me, it costs you $10. And you are now going to use math or mathematically to decide whether you like to play the game with me. And so don't reject it first, but I repeat again. Mathematically decide whether it's fair for you to play this game. Okay, so this is the situation. So you have a big bag, and now telling you that there's one ball of $50, one ball of $20, and nothing is $80. So whenever you get the ball, you need to pay me $10. So of course you see, wow, there are lots of $0 ball inside the bag. So of course you don't like to play it, but it's not mathematical enough. It's just your guess or your intuition or whatever. So that's why you have to decide whether you play or not about it. In this case, expected value plays an important role for you to decide it mathematically, because so now you can see is totally 10 balls over there, right? $50 is your value, so that means, okay, let's write 1/10 probability of getting $50, and then 1/10 to get $20, and 8/10 to give you $0. And finally, you see that, wow, you only get $7 as expected. Did you hear the word carefully? It is called expected value, right? Okay, so in the technical term is called expected value, but indeed it is the expected outcome when you play the game every time. So that means, well, if you play this game many times, in average, theoretically, you are going to get $7 each time. So if your cost is $10, So you better not to play with me because you will lose it at last, even though you are very lucky. But generally speaking, the more time you play with me, the more money you're going to lose. Every time in average, you're losing $3 to me. But if I change the cost into $5, I'm stupid because I'm losing money to you, even though I'm a host. So this is the situation about expected value. So in real world, then expected value can be talking about like the situation onward, talking about insurance. So maybe everyone or many of you, your parents help you to buy insurance to kind of like protection. But how the insurance company, how do they calculate the money you need to give to pay in order to get such a big amount? Touch wood if you have accidents or you get hurt, etc. Also, let's see the case of the girl called Julia. So the insurance premium is $180. That's something she needs to pay $1,800. If you have the way to estimate the situation like the probability, so now you can see her medical expenses. So these are 1, 2, 3, 4, 5 situations. Maybe she gets sick, get hurt, or kind of accident, whatever. So the probability are over there. Then she can decide whether $1,800 is a fair amount for her to do so. Alright, now let's calculate the expected value. That means what does she expect to get back from the insurance company? Okay, so 0.04 to return $40,000, 0.12 to get back $3,000, 0.25 times $2,500, 0.35 $1,500, and finally 0.24 and $700. This is the expected value that Julia may get back the money from the insurance company. So as a result, she finds that it's totally 1838, which is greater than the premium, the money she pays to the company. So that's why, yes, she does. She should pay. She should buy it. But of course, it's not really a very realistic question because you can't really find the probability of for each medical expenses. But in general, it shows you how, on the contrary, how the the insurance company decide what's the premium you need to pay for a certain insurance plan. And finally, you can use expected value to judge to every game whether it's fair enough for you to play so, to do so.